close the book on that. I cracked myself up. All right, now, okay, the last topic or topics, I'm going to lump them into one, before the next academic adventure that will be included on the academic adventure. The second academic adventure, aka test, I don't like saying that word, it's a dirty four-letter word, is we went through, started with balancing reactions, and then stoichiometry, lots in stoichiometry, percent yield, we did limiting reactants, and then from there we went into solutions and ionic equations, also known as precipitation reactions. And then from there we went into types of reactions. So this is all on that second academic adventure. And last but not least, it's called concentration. Get it? I was concentrating, I was focused. Okay, tough crowd today. Whew, I have to really earn my money. Concentration and dilution, dilutions. Here we go, concentration. Now concentration, that is how to express, I'm going to say how concentrated a solution is. What that means is like how much stuff is there in a solution. Remember, this unit's on solution right now. We're doing solutions, this part of the unit. And the solutions can be, well, dilute, or they can be concentrated. Like if you were to take and drink, go to the tap, take some water, drink it. Okay, you're not going to taste the salt in there. It's fresh water, but there is some salt ions, which could certainly there's some iron in there. Iron floating around. There's different things which can form salts, but you're not going to taste it because it's so diluted. Now, if you go to the ocean, take a glass of that and drink that. You don't want to go maybe even go because it's very concentrated in terms of what you're used to. So there's different concentrations of these solutes. The more solute you have, the higher the concentration. Okay, so you know that though, you know. And there's brackish water, which is in between fresh water. There's different levels of brackish. And so that has more salt that you could taste, but not as much as salt water from the ocean. So, all right. So concentrations are expressed in various ways. There's percent by mass, there's molarity, which we're not going to get into that in this class, more in later chemistry, yes, but in this class, you need to focus on molarity. And if we were in class, like you were here with me, and we're doing labs, we bring out a chemical, it's a solution, the liquidy solution, and you look at it, and the label is going to have a concentration in big M, that's molarity. So big M is molarity. So there are several ways, but we're just going to focus in this class on molarity. And since it says molar, it must have something to do with the mole, and it does. So molarity. And it's the big M. So if I had a solution out in the front table and it said sodium chloride 3M, or that'd be opposite. We say 3M sodium chloride, and you go, oh, that's a 3 molar. Okay, it's molarity of a 3 molar sodium chloride solution. Okay, molarity. How do we do it? Calculation time. It's an equation. All right, you will get a couple of these on the next exam. Molarity is equal to the amount of moles. The amount of moles over the amount of liters of solution. So this is the amount of moles of the solute. So I'll write that over here. Moles of solute divided by liters of the solution. And we're talking about water solutions here. So the liters of the water solution that this stuff is dissolved in. Now it doesn't have to be solid, but we're going to deal with just solids. It's the vast majority of our solutions in chemistry are solid salt dissolved in. It doesn't have to be salt either. It could be like sugar. But solid dissolved in our liquid water. Okay, so that's most of our solutions. So moles per liter of the solute dissolved in the solution. Now the solvent, solution. If we switch to solvent, we get, it's called molality, and that's a different thing. We're not going to go over that one. Okay, so what's an example of this? So let's say that, let's start with a simple one. You're given 520 grams of salt. Now, I mean, this NaCl, when I say salt generically, we're talking NaCl. It could be lots of different salts, but NaCl, sodium chloride salt. And you're going to dissolve this in 3,500 milliliters. Okay, 3,500 milliliters. What concentration would this be? What's the concentration? All right, molarity is moles over liters. Moles of the salt. Now, I don't have moles of the salt. Nah. No, you don't. But if you had to make a solution that dealt with this, you can go to a balance and mass out 520 grams of your sodium chloride and go measure out, this is going to be a water solution, 3,500 milliliters of water. You can go do that. And then you can figure out the concentration of it. Now, we are going to have to do a calculation because balances don't tell you how many moles. You, as the smart chemistry student, have to know how to get that. Okay, so let's go ahead and do this. So 520 grams of sodium chloride is not moles, and I need moles. So let's get this into moles, because that's my solute. And once I have that in moles, I'll put that on top of my fraction. And on the bottom, I'll put liters of solution. Now I have milliliters, but that's an easy conversion to liters. So let's get those moles. So 520 grams of sodium chloride times blah, so grams of sodium chloride. 1 mole goes on top. Add them up, me at 35 and 23 is 58. So how many moles of that sodium chloride do I have? Well, let's get the calculator out here and take our 520 and we'll divide it by 58 and we'll get 8.9. Now this, 2 sig figs, and that's what we have to start with. So, great, it comes out to be 8.965. So, okay, let's go back over those sig fig rules. So 8.9. And then stop and round it. What does that come out to be? That comes out to be 8.9. 9 rounds up the 8 to a 9, so 9.0. It comes out to be 9.0. We have to put the 0.0 to keep our significant figures. So 9.0 moles of the NaCl. Okay, so we have the top part of the fraction. We now have that. So I'm going to go ahead and put M for molarity. That's what M stands for. Molarity is big M. Is 9.0 on the top. What about on the bottom? On the bottom, we're going to take 3,500 milliliters and convert it to liters. Now, some of you might know at this point that you're just milling these 1/1000th. So you're going to shift the decimal point 3 places to the left, 3.5 liters. But we would do it like this. Factor labeling, milliliters to liters. Liters bigger, 1,000 millis in a liter, so you divide by 1,000, you get 3.5. So 3.5 goes on the bottom, and that's moles per liter. And that is what is defined as molarity, so go ahead and divide that out, and we get a salt concentration solution of 2 sig figs, 2 sig figs, 2 sig figs, 2.6. So 2.6 molar solution. For a salt solution, that's pretty concentrated. That wouldn't taste very good. Actually, that's over a pound of salt. It's only 424 grams, 454 grams in a pound. So that would be like over a pound of salt in your ew. All right. Some of you might be in the salty water though. So there you go. You've got your concentration. All right. Now, many times, however, in chemistry, me as the instructor or you as the student have to make your own solution. You have to make the solution. And you know what the solution is that you're trying to make. And so you have to figure out, how am I going to make this needed solution for the experiment? Let's do an example. Okay? Trust me. You're going to want to know. Okay. Let's say that you know that you have to make a 2 molar solution. A 2.0 molar solution of potassium nitrate. Okay, potassium nitrate. So that's what you know you have to make. Now, you need a certain amount of it. Let's say that you need 500 milliliters of it. So 500 milliliters, you know, it's half a liter bottle. You need 500 milliliters of this 2.0 molar solution. So you need this. Okay, need 2.0 mole solution potassium nitrate in 500 milliliters. You need 500 milliliters of it. Okay, that's what you need. So let's go ahead and figure out how would you do that. What you're going to have to do is go to your chemical cabinet and get some potassium nitrate. Then you're going to have to measure out how much to dissolve in your half a liter, 0.5 liters of water. How much? Calculate it. You got to figure out. You can't just dump it in and hope that's right. Okay, so figure it out. How do we do that? Use our equation. So here's what I know. I know the molarity of what I'm trying to find. I know what it is. It's 2. And we set that equal to the amount of moles that I'm going to need, which we don't know. We're going to have to calculate how many moles we need. But I do know on the bottom how many liters I have. I have 500 milliliters divided by 1,000, 0.5 liters. So I can now figure out how many moles of my salt, my potassium nitrate, I need. So go ahead and multiply those, cross multiply. You get 2 times a half is 1. Aha, this one came out easy. That was easy on you. So 2 times 0.5 is 1. So X equals 1, that's not a good one, 1 mole of potassium nitrate. You need 1 mole of potassium nitrate. So what do? You take your potassium nitrate, you go back to the balance, and you just dump it in until the balance reads 1 mole. Oh, there, half a mole, 3/4, 1 mole. I got my 1 mole. No, you know that balances don't read moles. You, the chemistry student, know how to do moles. The balance doesn't know how to do that, but it does know how to measure mass in grams. So figure out how many grams you are going to have to add to this water to get that right here, 1 mole of potassium nitrate. Okay, so let's do a mole to gram conversion. We can do those. Moles to grams. Do it now. So moles on the bottom, moles of potassium nitrate, and we'll go grams of potassium nitrate on the top. Oop, that is not. Get rid of you. Don't need you anymore. You're in the way. Make some room. And it's grams of KNO3. 1 goes next to the mole. Okay, we add up our potassium, our nitrogen, and our oxygen. So this is 39 and 14 and 32, 48. So that's going to be 39, 49, 53, 70, 93, 101. That should be 101. Well, let's recheck it and add it backwards. So 48 and 14, 48, 58, 62, 70, 82, 92, 101. Comes out to be 101 grams of potassium nitrate in a mole of it. So that's your answer. That's the answer to this problem. And the answer to this problem is, well, actually the question is how would you prepare? So if I ask you, how would you prepare a 2 molar solution of potassium nitrate in 500 milliliters of water, you would say, after the calculating, I would take potassium nitrate. On a balance, I would mass out 101 grams of it, because that's the amount in 1 mole, which we calculated from our equation. Got 1 mole of potassium nitrate. And I would measure that out by 101 grams. And I take my 500 milliliters of water, and I carefully pour it in. It's all in there, and then mix it up, and we're good. So that's how many grams you would need to add to your 500 milliliters. And I will give you a problem like that. Okay, you'll have to calculate how many grams of some salt that you'll have to add to make the solution that's desired. In this case, it was a 2 molar solution. All right, so that's concentration in molarity and 2 example problems. One, calculating the molarity, and one, figuring out how many moles you would need to make the wanted molar solution. Okay, you picking up what I'm putting down? Yeah. Okay, all right, now. The last little subtopic in the topic here of concentration in the unit that we're doing in Unit 2 of all the testy stuff is to do what's called dilution. Dilution. Let me give you an example of dilution before we do the chemistry. This is actually chemistry, but more of a down-to-earth chemistry example. Back in my day, I know, 1920s, my mother used to buy concentrated orange juice or concentrated grape juice. Now, some of you might still buy this. Some of you still might have this when you make orange juice. Most people don't. You don't see it very much, but you go to the frozen section, you buy frozen concentrated orange juice. All right, take that home, put it in the freezer. When you're ready to make it, you take it out, look at the instructions, take off the lid, pop it off, and you got concentrated orange juice sitting in that little cylindrical container. Now, if you wanted to, you can just dump it out into a container and wait till it melts and drink that. Ooh. Ooh. No, read the instructions. You have to add 3 things of water, always was hot water, so it dissolved the frozen concentrate faster. Smash it all up, get it all mixed, mix it up, you're ready to drink it. All right, tastes good, tastes fine. That is a solution dilution problem right there. You had concentrated stuff, and you had to add water to it to dilute it to the desired taste. Now, same thing with chemistry. Now, we're not going to be tasting chemicals, okay? We're not doing that. But my point is the same thing. When I order chemicals for the chemistry department, here at good old MCC, I am getting acids that are coming in concentrated form. When it's sulfuric acid, it comes in a bottle and it says 18.3 M, 18.3 molar. It's very concentrated stuff. When I order HCl, which we commonly use in lab, HCl, I order the HCl and it comes in, you look at the label, it says 12 M, 12 molar. That's concentrated hydrochloric acid. It's rare that you use concentrated hydrochloric acid. There are some labs you do, but it's rare. It's usually you do not use concentrated at 12 molar. You need something less concentrated. So what do? You mix it with water. Now, of course, you're going to add your acid to your water. Make sure you do it the right way. But you mix the acid and water together to dilute the concentrated stuff. It's the same thing. So when it comes to the orange juice, I mean, some of you might like to drink the concentrated orange juice. And so occasionally, you might use concentrated orange juice, but most people don't. You add water to get the desired. And that's what we do in chemistry. We add water to the concentrated in order to make the solution we want. And let's do a problem with that, because trust me, you will have to on the next academic adventure. And here's a typical problem. Okay. Let's say that I have a solution, and my known solution, okay, so what I have is my known, and I'm going to set this equal to need. Okay, this is what I have. This is my concentrated solution, and I need to make some diluted solution from the concentrated. Let's say I've got a chemical where I know the solution concentration is 8 molar. All right, you with me? 8 molar. Now, what I need is 3 molar. I need 3 molar. So I need a 3 molar solution of this solution. Doesn't matter what it is. It could be an acid, a base, or whatever, salt. I need 3 molar. Now, how much of it do you need? How much of it do you need? How much 3 molar do you need? Let's say I need 500 milliliters. Okay, I need half a liter. So I need 3 molar of this, and I need 500 milliliters of it. What I'm doing is I'm using what's called the dilution equation. It's a simple equation. I'll put it down for you. It's molarity times volume equals molarity times volume. It's the dilution equation. Dilution, D-I-L-U-T-H. I'll write it down. Dilution equation. Here it is. M1 V1 equals M2 V2. That means the concentration in, that's a 2. The concentration in molarity in the volumes of those solutions. V is for volume. Okay, so what I need is a 3 molar solution, and I need 500 milliliters of it. That's my volume. So what I do is I go to this side. What I know I have is sometimes called your stock solution. What you have in stock and what you're going to use to dilute and make the desired solution. So I have an 8 molar of the stock solution. How much of it am I going to need? That's what you're going to calculate. You're going to calculate the unknown volume of the stock standard concentrated solution. So let's go ahead and do that. Okay, let's do it. So what we're trying to do here is figure out how to make this. This is what I need. I'm going to figure out how would I make it? How would I make this? 3 molar, 500. How would I do it? So set up your dilution equation. Solve for the amount of the known, not a known amount of the known, amount of the stock, amount of the one you use more concentrated. Do the math. So that's 1,500 divided by 8. So it's going to be 1,500. If I multiply 3 times 500, I get 1,500. That's M. I'll show you what happens to the units. That's M, molarity, ML, ML. Divide, to get X, divide, bring that underneath, by 8m, the m's cancel, so when I take my 1500 and divide it by 8, I will get the amount, because ml's left over, milliliters. I'll get the amount of the concentrated stock solution that I need to make what I'm looking for. Okay. All right, so let's do the math. 1500 divided by 8. 1500 divided by 8 comes out to be 187.5. 100, I need 100. I said 87.5. I want to keep this with 3 sig digs. So I didn't do it, imagination. This is 8.00, 3.00, and 500 with the line over it. So it's 3 sig digs. So this 3 sig digs would come out to be 188. I should have been more aware of those sig digs when I started, but it's flying through it. 3. I typically make my problems with 3 significant figures. So I'm going to need 100. You ready? 188 milliliters of the stock, or the concentrated, this is the concentrated solution. I need 188. So I go back to my chemical cabinet, I grab the concentrated 8 molar, maybe it's an acid, and I pour out, carefully, 188 milliliters. Here's a large graduated cylinder. I pour it out, I got my 188 milliliters. All right, that's it, right? You're done. Problem's over. You know you need 188 milliliters of the concentrated stock solution, and that's it. The problem's done. No, the problem's not done. You're making a solution. So what do I do now? Well, at this point, if you calculate the amount of the stock solution, you have most of your points on a problem. You people are point-driven. I know you are. I know you are. How do I get full pointage? All right, so here's what you would do. Some of you might have thought this through already. So you know you're going to pour out 188 milliliters of that concentrated solution. Remember the orange juice example I used? This would be like my little container of concentrated orange juice. You pour that into a container, and then what do? Well, the directions say add 3 more containers, and you have it. So what do? You add water. You add water. So I have 188 milliliters of the concentrated, and I know I need 500 milliliters altogether. What do? Add enough water until you have 500 milliliters of the solution. So that's what we're trying to get to, is how much water do I have to add? 500, okay, that's the amount of this I want, the diluted solution, minus the 188 of the concentrated solution gives me exactly how much water I have to add to the concentrated solution. Remember the orange juice example, add water. So this is going to be 100, 200, 312. I'm going to have to add 312, and that's milliliters of water. So I'll take my concentrated solution, my 188, I'll measure out in this other graduated cylinder or volumetric flask. I'll take that and I'll add my pure water to that. I'll have 312 milliliters of the water. I got my 2, and I'm going to mix them. Now, if it's an acid, you'd have to be careful. If it's an acid, you have to add acid to water. I take the 188 and add it to the water. Okay, if it's a salt solution, if it's a salt compound or a salt solution, you just want to dilute a salt solution. You don't have to worry about that. It doesn't matter who you add to who. But if it's an acid, take the acid, the concentrated acid, and add your acid to your water, and you've got it. Okay, so to review, because I will ask you one of these. What you're going to first do is you're going to calculate how much volume of the concentrated solution you're going to need to use to dilute. So you put the unknown x for the v of the, put the x for the volume of the concentrated known stock solution. Solve for it. Then go, okay, how much of the diluted solution did I need? And I'll take that diluted solution amount, subtract the concentrated solution amount that I'm going to use, and I get the amount of water that I'm going to add. Okay, this doesn't make sense. Rewind and go through it again. Again, you can always ask me questions if you're in a Zoom about that, if that's confusing. So find the concentrated amount, subtract from the amount you need, get the water you need, mix them together. All right, I'll ask you one like that. Okay, that wraps up this second unit. And hopefully you'll be ready for the El Testo. Yeah, that's it. Round 2 done. We're halfway done, people. Actually, a little bit more than halfway done. Okay, yeah, we are.